know that yesterday we had taken a look at some of this stuff right here, and we'll finish this up, but I do want to get through the notes. And guys, we had talked about this idea of accounting principle. And we had said yesterday in the accounting principle that it uses what operation an awful lot? Multiplication. So up here on the board, I said we've got two soup options. We have two vegetable options, three fruit options, and one drink option. So today, when I put my box together, choosing one of each, how many options do I have? 12, yeah, multiply it all together, right? 12 different options, right? So again, you need to keep in mind everything is multiplication. Question, Seth?
That 3 looks like a .3.
It does. Somebody was throwing darts at my board one day and it chipped it.
Really?
Yeah.
Here. You did?
Here. Maybe
they were throwing darts at it?
Ah, yeah, it's cray-cray. Just cray-cray.
Oh, God. Are you using whiteouts?
More gooder?
Yes, it's much better. Thank you so much. I thought we would die if you didn't. Hi, Erin. Yes. For a second there, I thought you would have. For a second there, I thought you would have. I thought you. I'm not going to say that. I was going to say that.
All right. Very good. So guys, I want to kind of look at what we're talking about here in example 1. Example 1 actually says making a what? Tree diagram. I just want to verify what we're doing with this multiplication stuff today. When you see stuff that says make a tree diagram, don't worry about that too much. Okay, we'll look at this in the notes just to verify visually what it is that we're actually looking to accomplish today. So in this first example right here where it says make a tree diagram, let's just see if we can't model what's going on here. Again, this is another lunch application. And it says at a picnic lunch you can choose one sandwich, one salad, no problem. It says the choices include veggie burger, hamburger, or tuna sandwich. And then you have a garden salad and a fruit salad. This is how many different picnic lunches are possible. Well guys, we know we've got some sandwiches first, right gang?
Yes.
Whoops, didn't want to use that color. Okay, we've got some sandwiches, correct?
Yes.
Okay, what kind of sandwiches do we have options for?
We have tuna.
Got a tuna sandwich. I'm going to call that TS right here, okay?
Hamburger.
Got a hamburger.
Veggie burger.
And a veggie burger. That's always blown my mind, veggie burger.
Sandwich.
Veggie
Should we
burger.
write that?
You've never had one?
Well, I've had a veggie burger, but when I think veggie burger, I think of, I don't want to insult anybody or take this out of context at all, but I think of veggie burger, I think of vegetarian for some reason. And then when I say veggie burger, I'm like, okay, I'm confused. Is it vegetarian or is it
Tuna taste like? How about tuna sauce?
veggie burger like everything, like lettuce and tomatoes and onions and vegetables? Well, when I was in Charles City, when I grew up in Charles City, the veggie burger at the Dairy Queen was called the California burger. Well, so they call it the California burger at Dairy Queen in Charles City. Way to go. Way to go. All right.
What do they call it?
They call it the California burger.
Where is it from?
Dairy Queen in Charles City, Iowa. God's country. Or America's hometown.
No.
Yeah.
No.
Charles City is America's hometown.
No.
Yeah.
No.
I kind of know. I'm from there.
Okay.
Okay. All right. You guys agree there's 3 sandwich choices to start with. Would you all agree with that? Okay, so a tree diagram would be this. We're going through the lunch line. We say, here are the sandwiches. We got a choice of how many right here, gang? 3. Okay, so then all of a sudden, let's just pretend I took a tuna sandwich right here. If I took a tuna sandwich, then the next thing I would have is options for either a garden salad or a what?
Fruit.
How many options are there? When you're making a tree diagram, we kind of branch off of our first choices. With a tuna sandwich, I can either have a garden salad or I can have a fruit salad. You guys agree with that?
Yeah.
So one possible menu there is tuna sandwich with garden salad. That's one possibility, isn't it?
Yes.
Or it might be tuna salad with or I'm sorry, tuna sandwich with a fruit salad. Too many salads and sandwiches and tunas and, oh boy. I don't know about y'all, but I'm getting kind of hungry. Or what if I took a hamburger? Off of hamburger, if I chose a hamburger, then I could choose a garden salad or a fruit salad. Okay. Or off a veggie burger, if I would have chosen a veggie burger, and I don't know, I still have a garden salad and a fruit salad option, right? Now the assumption is we're taking everything. Guys, how many sandwich options were there?
3.
How many salad options here?
2.
Okay, when you're dealing with a tree diagram as it relates to counting principle, your tree diagram, figuring out how many possible outcomes there are for this, you always look at that farthest right part of the tree diagram. And in the farthest right part of the tree diagram, how many options are there just sitting out here? Count them all. 1, 2, 3, 4, 5, 6 right there, right?
Staircase.
Okay, with a staircase. All right, so how many options are there? 6 of them. Okay, John, you have a question?
Yes, I need to tell everyone in this room something.
Okay.
Do you know what a scone is? It's basically a cross between a cookie and a biscuit. My mom got some today, and I had one for breakfast, and let me tell you, it was heavenly delicious.
Heavenly delicious.
Yes, that means it was really, really good.
I don't know if I'll ever get scones because I think I'm destined to go to hell.
Why?
Well, if they're heavenly
My
delicious,
it was really good.
I don't know.
Do you know do you ever have a Schwann's person come?
Never.
Schwann. Why?
I live on a dead-end gravel road, probably. There's a reason why.
Why don't you just
Yeah,
call
let's
their
just
warehouse
drive all
and
the
ask
way
them
up
to get you
here.
some scones?
Get some scones. I'll keep that in mind. I'll text my wife. Get some scones.
Okay. Just want to ask them to like deliver it to you. They don't need to like.
Oh, next trimester?
We get a delivery
6.
truck out on
Yeah.
my
Yep.
house every Thursday.
Okay.
We don't live in a ditch problem.
So how many possible outcomes are there here, guys?
6.
6. Now keep in mind, how many sandwich options do we have? And how many salad options do we have?
2.
So we had said, you know what, take the number of options you have each time and do what with them? Figure out how many outcomes.
You times them.
Times them together. 6, right? Okay. All right, well, let's look at the second page here quickly. Guys, we're going to do this together. It says, suppose at each picnic lunch in example 1, you also get to choose a fruit. It says the choice is an apple, a banana, an orange, or a grapefruit. It says make a what again? Tree diagram to determine how many choices you have. So let's start with the sandwiches again. What were my sandwich choices? There was a veggie burger, tuna sandwich, and a hamburger, right?
Is it always veggie burger?
Well, that's because we're going right off the last example here, okay? So now we're getting a chance to choose a sandwich, a salad, and a vegetable, okay? So just like we had in the previous problem, off of the sandwiches we had either a garden salad or a fruit salad, right? And then we had a garden salad or a fruit salad. If we chose tuna sandwich or if we chose a hamburger, we still had a garden salad or fruit salad option. All y'all agree with that? Okay, now, I don't care what route you might have gone. You might have gone tuna sandwich to garden salad. You might be this person taking this right here. But now you have to choose a fruit. And what are your options for a fruit, guys?
Banana, apple, orange, grapefruit.
There's 4 choices, aren't there? So off of each one of the salads, how many branches are there going to be off of that for the choice of one fruit?
4.
There's going to be 4 of them. So there's going to be 1, 2, 3, 4 choices off of this, right? An apple, an orange, a banana, or a grapefruit, okay? And this is going to get repeated for each one of these salads, right? Isn't there going to be 4 branches off of each one of these now? There's going to be 4 of them here, and I'm not going to put the variables for them in there. But guys, if I do this, there were 6 salads out here, and off of each of the 6 salads, I'm putting 4 branches off of that, right? Well, if each salad had 4 options on there, 6 salads with 4 options on there, how many possible outcomes do you have now?
You used to 6 times 4.
Make the 6 times a 4. And think about it, guys. I'm not going to put the apple, orange, banana, grapefruit over and over and over them. But do you get the idea of what's going on here? Get the idea here?
24.
24 of them, right? So right here it says, the counting principle, it says if one event can occur in m ways, and for each of these ways a second event can occur in n ways, then the number of ways the two events occur is m times n. In other words, what operation between the number of outcomes for each situation? Times it, right? So here it is, guys. Again, how many sandwiches did you have here? 3 sandwich options. How many fruit or salad options did you have?
2.
And how many, this time, fruit
4.
options did you have? So to figure out how many total options I have to make a plate, or how many different plates I could make with 1 sandwich, 1 salad, and 1 fruit on it, what are you going to do with the 3, 2, and the 4? Times them together. 3 times 2 times 4, what do you get? 24 outcomes. And just like in the tree diagram, if I would continue over here, if I would continue right over here on the left, if I would have listed apple, orange, banana, grapefruit for each one of these salads right here, there would have been 24 different parts on the very end here. So you always count the far right of the tree diagram to know how many outcomes there are. Okay, so you have 3 times 2 times 4. And how many outcomes is that again, gang? 24. So you get the idea. We're just basically taking the number of outcomes for each situation, and what operation are you applying? Multiplication. Okay. Multiplication. So let's look at an example that involves counting principle. Let's get rid of drawing these trees, because this is repetitive, it's redundant. We don't need to do it if we know this right here, don't we? Right? Woo! Packer fans in the room.
Sweatshirt will make you sneeze in the
Hey,
morning.
what?
Where's the sweatshirt? It'll make you sneeze in the morning.
Will. Probably give me diarrhea too. I'm gonna have to wipe.
Hey, you can't.
Why not?
Because Green Bay makes cheese and it'll get you constipated. So that's why we call them cheeseheads.
Want to hear a good one? Did you know that all zombies are Packer fans?
Good.
Did you know that? All zombies are Packer fans. Did you know that? It's just like Packer fans, they're brain dead. I made that one up myself. That was pretty good.
They're not brain dead, they still have brains, that's what they eat.
Okay, let's get the counting principle going. Football's over. It's NASCAR time. You ready to watch them there race car go around that there racetrack? Okay?
Hey, who is the coach for track for the boys?
Brian Zook.
Who is that?
He's the assistant with us on
So
basketball bench.
everybody's track is going to start on Monday, right?
Optionally, you can't. We'll have a meeting about tomorrow. Let's focus on this here.
Should I
Okay.
go for track?
Huh?
Should I go for track?
All right, example 2 says, let's use this counting principle to figure this out. It says you roll a number cube and randomly draw a marble from the bag. It says there is 1 marble of the following colors: red, blue, green, and yellow. It says use the counting principle to find the number of outcomes. So we're going to go ahead and roll a number cube. When I say number cube, it just simply means a die. How many outcomes on my die that I'm holding up here? 6. Okay? So we're going to roll a number cube first. So when I roll this number cube, how many possible outcomes for that? 6. Then after that, kind of like what we did yesterday, right? Pick a number and then choose what color of marble you're going to get. Remember that stuff we were doing yesterday? Let's see if we can get this right.
Hey, you two need to still finish up a tie.
We took an eye on.
Well, no, we all had to get it right. Nobody got everything right, so nobody won.
Hey, I was close.
You were close. So was I.
Number cube 6.
Cheater.
Are we on the counting principle?
Now marble. Okay, how many choices of a marble do you have up there? 4. So the question becomes this. If I said, hey, here's a number cube, and here's a bag of marbles.
Over 6.
If you can predict
Green and yellow.
what number I'm going to roll on here, and then what color of marble I would draw out, how many different possibilities would you have? What are you going to do with the 6 and the 4? Times them together. How many numbers of outcomes are there? Well, there would be 24 outcomes, okay? So there could be like a 1 in a red, a 2 in a red, a 3 in a red, a 4 in a red, a 5 in a red, a 6 in a red. And then I repeat that 1, 2, 3, 4, 5, 6 all over for each of the 4 colors, right? 6 times 4. Make sense? Make sense?
Yes, it
Okay.
does. It makes absolute wonderful, perfect sense.
All right, so let's move the stones.
Yes, let's.
Okay, so you guys try this on your own right here.
Yes, let's.
You guys try that on your own. It says use the counting principle to find the number of possible outcomes in that situation. See what you come up with.
Okay, I'll need some marbles and a coin.
Hey, Parson.
Yes, sir.
Question.
Okay.
Would you have to count like them flipping the coin?
So flipping a coin or something else is 2. So you need a 2, yeah?
Hurry up!
What I
Faster.
Uh,
You really have
okay.
Okay, so in this example right here, the on your own, I'll read this quickly. It says you roll a number cube, you draw a marble from a bag, and flip a coin. It says there's 1 marble for each of the following colors, red, blue, and yellow. It says use the counting principle to find the number of outcomes. So let's just say this is the $1 million game. You have to predict what number is going to be up. You have to predict heads or tails, and then you got to pick the color of the marble that's going to come out of the bag. So knowing this right here, that first part that I put up there is the number cube. How many options do you have to choose from on a number cube?
6.
6. How about the number of outcomes
2.
for a coin if you flip it?
2.
2, heads or tails, right? And then finally, how about the marbles? How many marbles are there?
6. No, 3.
Looks like a red, a blue marble, and a
3.
yellow. So how many marbles are there, kiddos?
3.
Only 3 of them, right? All right. So the question becomes this. If I had to say, hey, you picked a number, you picked a side, heads or tails, and you picked a color of marble to be drawn, that's only like one way you can win, right? But how many possible ways are there here? So when I say how many outcomes are there, how many are there? 30 what? 36.
Yeah.
Yep. 36. Very good. How many had 36?
I did.
If I put the right number of marbles.
Then I did. You've got to count mine.
I got you. Very good. Okay.
Thank you.
So you understand how to come up with the number of outcomes. It's just each situation. How many outcomes for each situation, multiply them together. So let's put this in a probability aspect like we did yesterday. Okay?
Oh, my
We're going to find a probability. And it says the access code to a car security system consists of 4 digits. Okay? Some of the older cars, or maybe even some of the newer cars, I don't know. I don't have the amount of money to buy one of these cars, but they might have a digital code on the outside of them to unlock them.
That they have some in your Chevy.
Do they?
That's what OnStar.
But it just costs an extra $5 grand.
Nah, I'm not paying for OnStar. I'll never be OnStar anyway. They're too far away. Right? Right?
That's very true.
Okay, so you walk up to this car. Okay, you might say, gosh, somebody's locked out. We got to try and figure out a code here. Okay? And in this code right here, there are 4 digits. So I like to do this right here. Okay, there's 4 digits. Now, when we talk about digits, how many numbers are digits?
What do you mean? 4.
Sometimes they count the number of fingers that you have as your digits. These are called your digits. There's 10. You got to make sure you count 0 as one of them, right? So you got 1 through 9 already, right? There's 9, right? And oh, I got to add that 0 in there too. So how many digits are there? 10. So you can enter a 0 up to a 9. Maybe make that note right up here. Digits. Digits are all values. Digits are all values 0 to 9. Okay. So I walk up to this car. and I say the access code for this car security system consists of 4 digits. You randomly enter the 4 digits. What's the probability you choose the correct code? Okay. Well, there's only one code that's going to work, right? You got to get all 4 numbers. It's just like your iPhones or your Android phones. How many of you guys have a locking system on there?
I use.
How many use a code? How many use a 4-digit code? Let me guess.
I do.
3126. Do I have any of those numbers right?
Is
0000.
What did you say?
0001.
What did he say?
0002.
There's a 9 in it?
What's your iPhone do to you after you try so many times?
Locks you out.
Kicks you out, doesn't it? Why do you think they do that?
People just don't sit there.
So they can't get into it. They're going to lock you out, okay? Well, here's the deal. I walk up to this. Let's just say it's an iPhone this time. What's the probability I'm going to get that first number right?
1 out of 9.
1 out of, not 9, but 1 out of 10. How many digits are there?
4.
Oh, careful.
10.
There's a 1 in 10 chance I get that first number right. It can be a 0, it can be a 1, it can be a 2, it can be a 3, it can be a 4, it can be a 5, it can be a 6, it can be a 7, it can be an 8, it can be a 9.
And it could be a 10.
So, no, it can't be 10.
I thought it could.
No!
Yes.
A digit is one number.
Yes.
0, John,
Okay.
don't you be whacking up the universe on me, alright?
Okay. Well, I was
Let's
just
keep
having
everything
fun.
in balance, alright? I like balance.
What? I was
10, if you get a 1 in 10 chance of getting that first number right, right?
just having fun.
Okay, what's the second one? Well, think about the second one. Maybe I got the first number right. Now there's a second number I got hit in there. What's the chances I get the second number right? 1 out of 10. Right? 1 out of 10. Okay, because it could go 3, 3, right? Numbers could repeat, couldn't they?
Yep.
Kind of like on mine. You know what my code is?
0, 0, 0.
3, 1, 3, 1. Ryan Newman. Race cars. Vroom, vroom, vroom.
Oh, God.
Anna Walker, you should really sit down next Sunday and watch
Where's
Daytona
that?
500.
Who's Anna Walker? Is that? She's her name sounds a lot like Anakin Skywalker or something like that.
Her name is Annabelle.
What's the probability I get the third one right?
Annabelle, ain't it?
What's the probability I get the third one right?
1 out of 10.
1 out of 10. What's the probability I get the fourth one right?
1 out of 10.
Oops, didn't need to put another bar there. 1 out of 10. Guys, they want to say, what is the probability? Anytime they use this word probability, you need to put fractions in it. You're going to be multiplying fractions. We've done this. When you multiply fractions, multiply the top with the top. 4 ones up there. 1 times 1 times 1 times 1. What have you got? No!
Oh, 1.
Oh,
1.
No.
Okay, what's this 1 represent up here? That represents the one code that is correct, right? Help me out with the 10. Put a 1, how many zeros? Uno, dos, tres. 4 of them, right?
Over 1.
I walk up to this car with 4 digits. Think about this, guys. 4 digits. What's the lowest digit you can have? What? Like, all zeros, right? What's the highest one you can have?
9.
All 9s, like 9,999, right? If you would think 9,999 is the last one,
1, 0,
0, 0, 0, 0 is another 1 that you could add on to that. What's one more added on to 9,999? It is 10,000. There's a 1 in 10,000 chance you're going to get that right. You walk up to that car, who's got an iPhone right now with a code on it? Give me your phone. I'm going to unlock his phone right now.
No, don't do it. No.
Hey, no phone.
Okay.
You said we weren't supposed to have phones in class.
When I say it's okay, it's okay. I'm going to guess that his code is a 1, a 6,
He told you.
and an 8.
Is it right?
He told you. I heard you asking.
Yeah, you read that.
What do I get for winning?
When can we have our phones out? Never.
Only when I say so. Here's the deal, guys. Honestly, think about this. There'd be a 1 in 10,000 chance I got that right. He's got a 4-digit code there. Perfect example, right?
So it's 1168.
Yeah, 1168.
I'm
Got
gonna
it
go
down?
tell my friends that.
All right. Anytime they use this word right here in your problems, right here, what's the word I'm pointing at?
Probability.
You are multiplying not just whole numbers anymore, like we were with outcomes up here, but you're multiplying
Fraction.
fractions. Okay, so let's try this on our own together. I think that this will be a good one to talk about.
Woo!
A lot of computers have passwords now, right? Like right over here. Here's the password. It says the computer password has 2 lowercase letters followed by 6 digits. Find the probability you choose the correct password. What's the word I'm going to underline right here?
Probability.
Are we just taking outcomes, number of possibilities, and multiplying together, or are we multiplying fractions now?
Fractions.
Okay, first thing it says that we had here was 2 what?
Lowercase.
In the alphabet, in that there alphabet, how many of them there letters are in that alphabet?
Will be a ding dong dang.
How many letters to the alphabet, kiddos?
26.
Okay, we're going to have 2 letters. We're going to have a letter and a letter. Okay? So the chances that I get a letter right first, oops, I want to move that down.
What is the fish? Did you draw 2 fish up there?
It's a letter L.
Okay.
And then it's going to be followed by 6 digits. A digit, a digit, a digit, a digit, a digit, a digit. Okay, so these first 2 right here really represent my 2 letters, right? Like my password would probably be JP. My password would probably be JP. 2 lowercase letters, right? Okay, so what's the probability I'm going to get this first one right, Anna? You told me the number.
26.
So there's a 1 out of 26 chance I get the first letter right. Would we all agree with that? Then there's another letter. So the second one right here, what's the probability I get the second letter right? 1 out of, yeah. Okay, so now then we're going to start throwing digits in there. And how many digits did we say we had?
9, 10.
Not 9, but 10 of them, right? So just like up top here, what's the probability I get this first digit right?
1 in 10.
How about for all the digits?
1 in 10.
1 out of 10 for all the digits. Oh my gosh.
126 for the first 2.
Okay, I'm going to bring my calculator up here. Now, guys, the question is this, all right? Say I'm a computer hacker. Not a very good one. This is protected with a password. We got to get in with a password. And the password we know has 2 letters to start and 6 digits following it. The question becomes the following. If I walk up to it and type in one password, what's the probability it's right? Well, obviously all the ones up top multiply to what, guys?
1.
Multiply to 1. I don't know where I'm going to squeeze this in at.
Can we take times it to like a power, like 10 to the 6th power? Or
Could.
times-
I'm just gonna times them though.
Oh, good lord, there's a lot.
Okay, it's 676. This is
Here's what I like to do with
Million.
zeros. Watch what I like to do with the zeros. I'm gonna do the 26 times the 26 here. Is that okay?
yeah, it's fine. We don't care. It's your decision.
Okay, I've done 26, 26. What have I got here, guys?
676.
When I start multiplying by 10s now, I just start adding some what to the end of it? Zeros to the end of it now. So how many zeros does it look like I'm gonna add?
They need at least an hour.
6 of them, right? All agree? All agree?
Yes.
So I'm gonna multiply this really by a 1 followed by how many zeros?
6.
Okay, can I run around the upper gym? I don't care. I won't mess around.
So there's 1, 2, 3, 4, 5, 6 zeros. That's what this mess would be right here. And that's kind of what John was alluding to. Can't we just go 10 to the 6th? Which is a 1 followed by 6 zeros, right? There's your value.
Oh, God.
Looks like 676 million. Is that right?
Yes, that is exactly right.
Okay. So, hey.
Excuse me. Hi, Chelsea.
What is it?
1 in 676 million. Okay? 1 in 676 million.
Okay, I'll burp really loud.
So, here's this computer. Knew that was coming. What happened?
Sorry, the schedule.
Sorry. I thought I locked myself out by accident.
It,
No, twist it up like that.
That's okay.
it dawned on me when I saw the time, our schedule is, and so
Yeah.
he needed to go to the office. So, sorry.
No, it's
Should've
okay.
caught that earlier.
It's okay.
Yeah.
I walk up to this computer. I'm going to hack it. What's the probability I get that password right the first time?
1 in 60.
1 out of
676.
676 million. Kiddos, what questions have you got on this? A lot of multiplying,
I
right?
dare you to try to.
If they use the word probability, you need to put stuff in what kind of a form? Fraction form or just regular numeric form? Fraction form. They use the word outcomes, and that's just going to be some whole numbers, okay? So, based on what we did yesterday with that experiment, relating it to what we did in the notes today, are we okay with this stuff?
Yeah.
Okay. I do have a short book page for you, so take a second and write this down, and I'm going to try and squeeze a quick quiz in on you, but I don't think we're going to get it down, but you can take it with you. Write this page down. We're going to do page...
What time do we leave here?
56. Page 156, 3 through 3. Yeah.
Okay, it's page 315. And I'm going to ask you to do this for Monday. It's problems 3 through 7, number 9, and numbers 11 through 15. And we'll make this due for Monday. Okay, so we'll make that due for Monday right there. Oh, so pretty. And I think I'm going to hold out on the quick quiz. Is that all right with you guys?
Yeah, it's awesome. It is absolutely.
Sorry to break your hearts.
Can we check something on our phone?